So let's say that we want to graph this ellipse here and identify some of the key features. So the first thing you want to do is identify the center, which is going to be at, you switch that, and then you switch that. So the center, C, is at 2, -3. So we go to 2, -3, and that is our center. Now look, do we anticipate the ellipse opening sideways or vertically? Well, look at the denominators. This is a larger denominator, so it's going to be swayed more with respect to y, meaning up and down. So if x had a bigger bottom, it's more sideways. If the y's have a bigger bottom, it's more up and down. So I anticipate this is going to open something vertically. Now, square root, square root. If I square root that, I get 5. If I square root that, I get 2. Now the square root, 5, since it's associated with y, from the center, you go up and down 5. So let's go 1, 2, 3, 4, 5, like a point right there. And then from the center, go down 5. 1, 2, 3, 4, 5 here. I mean, it's not the best drawing, right? This is really not drawn to scale. Now look, 2 was the square root, and 2 is associated with x, which is side to side. So from the center, go to the right 2, and then go to the left 2. And now you have these 4 points, which can help us, they guide us with our artistry here. So when we connect these points with an ellipse, there it is. That's the general graph of the ellipse. But let's say that we want a few more things. The vertices versus the co-vertices. The vertices are always along the major axis. This is the major axis because it's more up and down. Now the coordinates there, if you just count on some graph paper, should be 2, 2, and the other one should be at 2, -8, it looks like. And then, so the vertices are the ones that are far away from each other. The co-vertices are the ones that are closer to each other. And those coordinates there should be, it looks like it's 4, -3. And the other one should be at 0, -3. And notice that the co-vertices have something in common with the center. The co-vertices have something in common with the center. Now, what about this? If I go vertically, this here, this is called the major axis. So the major axis, and a lot of times you tell them how long the major axis is. So if you count these boxes, it should be about 10 spaces. And then the minor axis, the length of it would be this little guy here that goes like that, right? So the major connects the ones that are far away, because it's more vertical in this case. And then the minor axis is the one that connects the closer together. And those should be 4 units. So 10 units and then 4 units. And really the only thing left to give them, I'll switch colors. The only thing left to give them would be the foci. Now the foci are points that are along the major axis. Now here is what we do. So we know that for ellipses, we have this equation. A squared minus b squared equals c squared, where a squared is bigger and b squared is smaller. So you know that this is a squared and that this is b squared. And what we have to do is find c. So the bigger one is a squared, the smaller one is b squared. So take 25 and 4 and drop them in there and there. So this has a direct replacement of 25 minus 4. So a squared is 25. You don't square 25 because 25 is a squared. 25 minus 4 is 21. If you square root, c is the square root of 21, which is like 4 point whatever, 4 and change. And what you do with the number c is you go to the center and you walk toward a vertex and you move 4 point something spaces. So from here, I'm going to go 1, 2, 3, 4 spaces and change, and I'm going to stop there. And then from the center, go down, because really it's plus or minus. Whenever you square root, it's plus or minus. So at your center, go down 1, 2, 3, 4, and a little bit more. And so you can see that the foci are always inside of your ellipse. Always, always, always. Now, what are the coordinates here? What are the coordinates there? Well, here's how I like to think of this. For the foci, what you're going to do is copy the coordinates from the center. You can borrow the information from the center, which is at 2, -3. Now, we're going to manipulate one of these coordinates. Are we going to manipulate the x or the y? Well, make a decision. From the center, which is here, did we go sideways or did we go up and down to find the foci? Clearly, we went up and down. So if you go up and down, that's a modification upon the y coordinate. So what you do is you go plus or minus to the y coordinate, whatever c was. In this case, square root 21. So if I write this a little nicer, boom, these are the exact coordinates of these special points called the foci. This is a focus, this is a focus, plural foci. And again, the foci almost look exactly like the center, right? The foci, but one of the coordinates of the center gets manipulated because again, the foci are obtained by going to the center and either walking up, down, or left, right. And I think that's all they wanted. These are all the major things that they usually ask for. And again, you don't have to write this twice, just write. So yeah, so that's how a problem like this can be done. Now here we're given some random pieces of information, and what they want is, they want the equation. So I need a visual. So maybe we can go to the XY axis and plot these points. Now, you know what we can do is, if this is the center, and if from here to here, if you went up 8, it looks like from there you go up 8. So then you have to go down 8 spaces. Here to here, these are 1, 2, 3 spaces apart. So go 1, 2, 3 spaces apart. And then we can actually draw our ellipse. And now that we see the ellipse, we can decide, are we gonna fill out this template or this template? Well, this is clearly more vertical. So we're gonna use this template here. So what we can do is we can identify the coordinates of the center as being h and k, because that's what they are. So in your template, you can take 5 and drop it in for h, take -1, drop it in for k. And if you respect the whole double negative aspect that can occur, this is what we should get here. Let's see. So I plugged in 5 for h there, -1 for k there, double negative turned it into a positive. So h and k get filled in. Now let's fill in a and b, and then we're done. Because it always equals 1, and it's always the bottom squared. But what's a and what's b? Well, remember that a is greater than b when we talk about ellipses. So if I grab this pink marker here, go to the center. If I go up toward the sky or down, doesn't matter, how many boxes would I be moving until I reach the vertex? If you count or if you rely on the numbers, however you want, it should be 8 spaces. And so 8 here, since I moved 8 spaces vertically, I go to the y's, and associated with y, I put 8. Because that's how much I moved in one direction, either up or down, doesn't matter, to get to a vertex. Now, what about side to side? How much is it to go from here to here? Side to side is x's. So from the center to the edge, that looks like it's going to be 3 spaces. So 3 goes in here, right? Now, as an FYI, the major axis would be 16, and the minor axis would be 6. They didn't ask for that. They just wanted the equation. This would be it right here.